In this lab, management has told us to set up a local and remote switched port analyzer on the network. Packet sniffing allows us to monitor and analyze traffic on a network. Cisco switches provide two main methods: local span and remote span. Let's start with local span. Span stands for Switched Port Analyzer. Local span mirrors traffic from source ports to a destination port on the same switch. For example, at a company, you may want to monitor all incoming and outgoing traffic to a critical database server. You can set the database server switch port as the span source to mirror all its traffic. This allows you to connect a packet capture tool like Wireshark to analyze traffic to and from that important server for performance or security purposes. To intercept and analyze this mirrored traffic using Wireshark, you would connect another device like a laptop or PC to the destination span port using an Ethernet cable. On that monitoring device, you would install and open the Wireshark application. In Wireshark, you would select Ethernet port, as that's the port you're using to connect to the switch destination span port as the interface to captured packets from. As traffic gets mirrored from the span source ports to the span destination ports, Wireshark will now see copies of those packets and record them. Once capturing traffic, you can use Wireshark's analytics and filters to analyze the monitored network flow in detail. For example, you could isolate traffic from a particular IP address, protocol, or look for some sort of abnormality. Wireshark gives enhanced visibility into the mirrored traffic since it can decode and visualize the packets. In summary, the mirrored span traffic is sent from the source port to the destination port. By connecting another device, such as a dedicated packet sniffer device, or just a laptop running Wireshark pointed at the source port, you can intercept and analyze the copies of the monitored network packets. In this first task, we're going to focus on local span, which is used to duplicate traffic from one port on a switch to another port on that same switch. To configure local span, we first need to create a span session and define the source port. In this case, we want to investigate the traffic from user 1, and user 1 is connected to Fast Ethernet 0/1. So, in the switch, we'd use the command monitor session 1 source interface Fast Ethernet 0/1. This sets Fast Ethernet 0/1 or FA 0/1 as the mirrored source for session 1. Next, we have to specify the destination port our sniffing device is connected to, which is Fast Ethernet 0/3. So the command here is monitor session 1 destination interface Fast Ethernet 0/3. This sets FA 0/3 as the destination for the mirrored traffic. Now, any traffic on FA 0/1 will be copied to FA 0/3 for monitoring. To verify or troubleshoot span, we can use 4 different commands. We can use show running configuration to see where monitor session 1 source and destination interface are. Using the command show run pipe, which is that up and down line, B for begins with, and then typing in monitor, it shows the running configuration starting at the line that has the word monitor. We can use show monitor session 1 detail, which will include type. So this indicates the span session is a local span session, meaning that it is monitoring traffic within the same switch. Description. So this field displays the description of the span session if we had configured one. In this case, no description has been configured. Source ports. This section displays information about the source ports being monitored by the span session. The RX only field shows ports that are being monitored for received traffic only. That's what RX stands for. Received. The TX only field shows ports that are being monitored for transmitted traffic only, which is what the TX stands for, transmissions. And the both field shows ports that are being monitored for both received and transmitted traffic. In this case, port FA0/1 is being monitored for both received and transmitted traffic. Source VLANs. This section displays information about the source VLANs being monitored by the span session. Similar to the source ports section, it shows VLANs that are being monitored for received traffic only, transmitted traffic only, or both. In this case, no VLANs are being monitored. Source RSPAN VLAN. This field displays the RSPAN, remote span, VLAN being used as a source for the span session if one had been configured. In this case, there is no RSPAN VLAN as we have not configured it, since this is a local span. Destination ports. This field displays the destination ports where the monitored traffic is being sent. In this case, the monitored traffic is being sent to port FA0/3. Encapsulation. This field displays the encapsulation type used for the monitored traffic. In this case, the encapsulation type is native, which means that the switch is using the default VLAN tagging behavior for the monitored traffic. Ingress. This field indicates whether ingress traffic, which is traffic entering this destination port, is allowed or not. By default, ingress traffic is disabled to prevent the destination port from allowing traffic into the network. Filter VLANs. So this field displays any VLANs that are being used as a filter for the span session. In this case, there are no VLANs being used as a filter. Destination RSPAN VLAN. So this field displays the remote span VLAN being used as a destination for the span session if one had been configured. Again, in this case, there is no RSPAN VLAN as it's not been configured because this is a local span. Using Show Monitor Session 1, you'll see a summary version of the Show Monitor Session detail view. And Show Monitor Session All can be used to see the same summary view, but for all monitoring sessions that might be on a switch. In this case, there's only the one we set up. So, in summary, we can view and troubleshoot the span sessions using either Show Running Configuration, Show Monitor Session ID Detail to see the details of a particular session ID, Show Monitor Session ID for a summary of that monitor session ID number, or Show Monitor Session All for a summary of all span sessions. Make sure to save your configuration with Write and also save your packet tracer file. Then we'll test out our new mirrored traffic in the packet sniffer device before we move on to the RSPAN. First, we need to create some traffic from user 1 to look at those captured packets. From user 1's command prompt, let's ping user 2's PC. Then from user 2, let's ping user 1's PC. Now let's open up the sniffer and click the GUI or Graphical User Interface tab. Click on the ICMP or Internet Control Message Protocol data packets, which were the ones we sent with our pings. Inside, we can see what that data packet looks like. At the top, we have the OSI layer 2 Ethernet frame data with its source and destination MAC addresses and frame check sequence number, which is represented at the top here by the sniffer. Then we have the layer 3 IP packet with the IP version number, the time to live for the packet, which is how many hops it has left before being destroyed, and the source and destination IP addresses. This packet is an ICMP data packet that uses UDP instead of TCP as a transmission protocol, so there is no TCP sequence or session ID. Here we have some ICMP protocol information like the sequence number. And then finally we have the PDU data itself. Feel free to pause here and play around with the packet sniffer before we move on to RSPAN. RSPAN stands for Remote Span. it forwards mirror traffic across multiple switches to a destination port on another switch. This allows you to centralize your traffic from a bunch of different switches to one network capture device. For example, at a large company, you may want to monitor all traffic flowing between the engineering and sales departments, which are on different switches. You could designate source ports on the engineering and sales switches and forward the mirrored traffic across the network to a destination port on a monitoring switch. This allows network security to analyze interdepartment traffic on one central switch using an attached packet capture device. To capture RSPAN on a source switch, which in this case is switch 2, first we need to create the RSPAN VLAN to transport the mirrored traffic. In this case, management told us to use VLAN 10 for the RSPAN. Next, we need to enable RSPAN with the remote span command. Then we define the source port and the RSPAN VLAN with the command monitor session 1 source interface FA0/1. This sets FA0/1 as the source interface for monitoring session 1. Next, we need to tell the switch that monitoring session 1 should send traffic from VLAN 10 to a remote reflector port on the unused port FA0/5 with the command monitor session 1 destination remote VLAN 10 reflector port FA0/5. On the destination switch, we then have to set up RSPAN to receive the traffic. We need to configure the same VLAN ID, VLAN 10, on this switch so the tagged VLAN traffic can be recognized here. Remote span here is to enable remote span for the VLAN. Monitor session 1 destination interface FA0/1 is here to set the destination interface for the traffic as FA0/1 for monitor session 1. Monitor session 1 source remote VLAN 10 is used to configure VLAN 10 as the remote source for monitor session 1. Now, save the configuration, save the packet tracer, and update your work documentation notes. Now, take your notes and create a narrative explaining everything you did. Also, feel free to play around with the sniffer on the remote span. Then, share your lab folder, which should contain your completed packet tracer file and Google Word doc, notes, and narrative. Using the anyone with the link can organize, add, and edit access so you can submit your lab for review. If you don't know how, refer to the instructions in the lab's intro video section of this program. After you submit your lab, you can move on to the next one.